Okay, so today we're going to learn about how to evaluate the performance of decision trees and also neural networks. We're just going to learn general machine learning metrics, and then we're also going to learn about clustering. So the very first thing we're going to do is we're going to load in this library for the very first time. I already have it loaded. If you haven't loaded it for the first time, it'll take quite a bit of time because it's installing from GitHub. Okay, then we set the working directory. We're going to load the tidyverse library, set the seed, eliminate exponential notation. Okay, so now we're going to go to the Toyota Corolla dataset, which is predicting the price of the Corolla, and we're eliminating all of these things that are not numerical values. And we're doing that because we want to run a regression. So we're going to run a regression on price, and we're going to compare it to a decision tree and see what the differences are. Oops. Let's run all the way to the bottom. And it actually switched something else. Okay. All right, so now we're going to do our split. So we're going to put 60% in training set, 30%, 40% in the holdout. So let's just make sure that that's been done correctly. So you see car DF is 1436, train DF is around right, and then holdout DF is 573, which is about 40%. Okay. Okay, now the very first thing we're going to do is we're going to do linear regression. So we take linear regression, price as a function of all the other variables, train, and we're going to predict on the training set and then also predict on the testing set. And then we're going to start off with very simple root mean squared error. So you see this is 1045 on the training set and 1400 thereabouts on the testing set. Now we can calculate more stuff. Okay, we're going to use this interesting function called regression summary, which will give us the mean error, the root mean squared error, and the mean absolute error. And of course, ultimately what we care about is holdout performance, but what the differences allow us to look at is what the error is, if we're overfitting or not. Okay, now we're going to do a whole bunch of utility code to plot this beautiful graph. Okay, so the very first thing we're going to do is look at the training residuals. So remember what the residuals are. They're the difference between the predicted value and the actual value. And we want these to be distributed around 0 approximately evenly. If they're not, if there's a systematic change or if it's asymmetric, we can almost certainly improve the model. And then residuals on the holdout data set, and then finally a box plot, right? A box and whisker diagram. Okay, and then we finally plot all of these things. And so what you see is we see approximate symmetry, and then we look at the holdout period. They don't look radically different, right? The median is around 0, bottom quartile, top quartile, they're about the same. Okay, so probably not a lot of overfitting. Okay, now we're going to compare this to a decision tree regressor. Okay, so we're going to use our part library and then price as a function of data, and then we're going to do the same things. Here we're going to use a slightly different way of printing out the RMSE values just so that you can see it. And here we get our first interesting result, okay, which is the training RMSE is 1324 and the holdout RMSE is 1610. And as you'll remember, this is actually quite a bit higher than what we had before with our linear regression. We had 1045 and 1400. And if we print out all of the numbers, the detailed summary, you'll also see that they're quite a bit higher. So if we look at mean absolute error, here we have about 1,000 and 1,100. And if we go up here, we have, those two are identical. No. So I scrolled up too far to where I had done it previously. Okay, so you see that they're actually significantly lower. Okay, 800 and 900 versus 1,000 and 1,100. So you see that linear regression actually outperforms the decision tree regressor. So this is a good lesson. This is why you always use a baseline and why you always start off with something super simple like linear regression or regression, and then just using the most popular class for classifiers. So the next thing we're going to do is we're going to evaluate classifier performance.